Good morning. I'm Tom Radcliffe, the Director of Engineering at ActiveState, and joining me today is Clif Flynt, the President of the Tickle Community Association and also the President of Numina Corporation, who's been involved in Tickle for many years, and we're going to be talking about the active state of Tickle. Welcome, Clif.
Okay. Hi. Nice to be here, and thank you for inviting me. I've been involved with Tickle since '95 was when I first started working with it, and started running the community association about 12 years ago now. I started running the conference, and also wrote one of the books and one of the tutorials on the language.
Cool. And I am a physicist by education. Casual user of Tickle because it is everywhere, as we'll talk about. I used a product called VDK, the Visualization Toolkit, very heavily in the medical physics, medical visualization industry, particularly in the 2000s, and they did all of their testing driven through Tickle and TK. Subsequently, have worked as a consultant mostly in medical physics, and have been ActiveState Director of Engineering for almost a year, over a year now, where I've gotten reintroduced to Tickle. So your depth is much greater than mine, Clif. You want to walk us through where Tickle came from?
Okay. Tickle started at UC Berkeley when John Osterhout was doing work in electrical circuit design, and basically they were building circuit simulators, and every time they would build one, they'd need a way to configure it and say, this is what our circuit looks like. And every time they did that, they built a little configuration language, and every one of them was different. So after 2 or 3 of these iterations, this is not what they've ever said, but I think went on behind the scenes was, we've built 5 bad interpreters, let's build a good one. And took what they had learned to build Tickle, which was designed to be extended with their new tools and embedded into their other applications. When John introduced it at the Usenix conference in 1990, he really thought that the library was going to be what people would use, because back then everybody wrote in C. And it was a way to merge in an interpreted language into your C program quick and easy. He got surprised, but
yeah, well, I think it speaks to the practicality of the language that came out of this repeated use case where they were trying to solve a practical problem, kept on hitting the same issues, and we've all done this by throwing together a little software tool that turns out to be bigger than we anticipated. So it wasn't like some languages are sort of a dream in the inventor's head where they have an ideal that they're pursuing, whereas Tickle was very much, we have some experience solving a particular problem. Our solutions so far haven't been very good. Let's take what we've learned rather than take some ideal and build a language around that knowledge. And I think that that is one of the reasons for Tickle's success, is that very practical and knowledge-based focus.
yeah, I've thought Tickle and C are 2 languages that were built by pragmatists.
Yeah, very much.
They do anything.
Yeah, yeah, and they were built around solving slightly different problems, so they're solving different they're different languages, but definitely neither of them are things that are going to make a certain type of language purist happy, but they make an awful lot of users happy, which is what ultimately we care about. And it is, I think it's interesting that even given, I mean, maybe even because of this pragmatic focus, Tickle did get the ACM Software System Award for 1997. And that, to me, reflects, if you look inside many languages, the code inside is not necessarily very pretty. Whereas Tickle code, the internals of the interpreter are really quite clean and solid.
Yeah. Yeah, especially the early Tickle, you could just read it like a novel.
Yeah. Yeah. It's highly portable because of that.
Yes.
One of its strengths. So let me see. Ha! here we go. So that brings us to something like the present day, or at least the last decade, where we do see, and we'll talk about some of the new developments in Tickle and TK.
Yeah, it's constantly in development. There's a core team of about 20 people that are, and probably half again as many just plain developers that work on the language. If you're on the core mailing list, you see there's a new feature suggested and going into testing or performance improvements. Almost every week there's something that gets committed.
Mm-hmm.
Currently at 8.6.6, 8.6.0 was when we introduced object-oriented and coroutines into the mainline Tickle.
Right.
Object-oriented, like Inker, has been around for a long time, but it was an add-on.
Yeah, and Tickle 00 is now deep in the language. And I have to say, as somebody who comes from a C++ and Python background, using Tickle 00 just feels like perfectly ordinary object-oriented programming. You know, it makes the language very familiar to an object-oriented programmer.
Yeah, I like Tickle 00 because it's a good dynamic 00 language as well as being clean 00. Inker Tickle reflects C++, and that doesn't always reflect well into the dynamic world.
Yep. Yeah, it is. It's a very mature object system. And I know it's had some, because it had considerable history in the language prior to 8.6. So there was solid incremental development. And clearly the community and the core development team waited until it was a mature, well-engineered piece of machinery before bringing it into the core language.
Yeah, one of the places where Tickle does get used occasionally is by guys doing language research. University Delft, I think it is. Sorry, I just dropped the name of the guy who did ExoTickle.
Okay.
But what his group does is researches new techniques for doing object-oriented programming, and a lot of his ideas were what flowed into OO-Tickle.
Okay. Yeah. And I have to confess, I wasn't actually aware that coroutines were in 8.6, but that's another very powerful modern language feature that it's good to see in this language.
Yeah, and there's a lot of functional programming, currying and things like that that we don't normally use, but when you need them, they're there.
That's good. That's good. Yeah, most modern languages, I think most practical languages are taking a multi-paradigm approach, that they're recognizing that there are different ways of approaching different problems, and sometimes you want a functional solution for a certain aspect of a problem. At other times you want no solution. At other times you want just procedural glue to hold it all together. And I think from a practical programmer's point of view, having all those tools available in your toolkit makes life much easier. So it's good to see Tickle is aggressive about adopting those.
Yeah.
And still manages to keep its syntax clean and simple. That's one of the things that amazes me about the language, is you can practically state the syntax in a paragraph.
Yeah, with 13 rules.
Yeah, and that's considerably simpler than C++.
Yeah, it's even simpler than C, which was a revelation at the time when it came out.
Yes, yeah, it's become more complex since. Do you have any sense, and this is a terrible question, but I'll ask it anyway, of what the timeline for Tickle 9 might be?
No.
I won't go with anything you say.
Yeah. I know it's being actively worked on, and we're falling into the same thing that we did with Tickle 8.5 when we decided that there would be no Tickle 8.6. We would go straight from there to 9. Well, this feature can go in easily, and we really want it.
Yeah.
Tickle, I forget which Tickle 8.6 was going to be the last thing before 9. It might have been 8.6.3.
Yeah. Yeah, I know. And I've obviously talked to people on the core team, and there is, so far as I know, not a super clear timeline at the moment, and yet the language keeps on getting create new features. So in one sense, it's not that relevant. It's just a curiosity.
Yeah. The philosophy in Tickle is that major changes are not necessarily backward compatible.
Right.
So anything that was written for Tickle 7 might not work in Tickle 8, and stuff
Right.
written for Tickle 8 might not work in Tickle 9. So 9 is our chance to go through and break things.
Yes, and that is a good opportunity to have. And there's one of the other points here is the active work on Windows integration.
Yeah.
And that is something I know that most dynamic languages, most developers are not super enthusiastic about Windows, and yet we all have to go there sometime. So having a language that has solid cross-platform support and makes Windows a first-class citizen in its ecosystem is very important. It's always nice to potentially integrate.
Yeah, I just went through an iteration with an application that I wrote for pure TK. Runs on Windows, Mac, and Linux, of course, very easily.
Yep.
And then a potential customer said, doesn't it integrate with Word? I really need it to integrate with Word.
Uh-huh.
And I said, oh, no, there's just no way. It just can't. So I'm using it with Word now a week later.
Yep, yep, that sounds about right. That's good. And of course, at ActiveState, we support not just Windows, Mac, and Linux, but also AIX, Solaris, HPUX, some of these more exotic machines. And Tickle is, is portable to those environments and gives you the power of this modern multi-paradigm language on your old HBox box.
Yep, and also on an Android or on a Raspberry Pi.
Which is very cool. The Android especially, which I think we will have something about the future. Uh-oh, yes. Tickle Trends, there we go.
Yeah.
So AndroWish is a Tickle interpreter for Android?
Yep. And when I first found out about it, I took one of my Tickle games, and a half an hour later it was running on the Android.
Oh, that's amazing.
Yeah.
And can you download it from Google Play?
That one, AndroWish, no, actually I don't think AndroWish is on Google Play. You have to go to the AndroWish site, which you should have put on there.
Okay.
But once you've compiled something, there's an AndroWish SDK that will compile things down and make a regular executable. And yeah, I've put things onto the Google Play, and just mostly to prove that I could do it.
Okay. So you can take your Tickle code and compile it down to something that will just run on Android.
Yep.
That's amazing.
And it uses the Android features. So I made a little shopping app where you speak what you want into the phone, and it says, you want this. And
well, that's very cool. Yeah. That I've done very little mobile stuff, but that makes me want to rush out and build a mobile app just because I can.
Yeah, and most of it is just plain old Tickle. You make a canvas, make a screen.
Yeah, good. And TK, of course, has gotten some attention in the last few years to give it more modern look, basically, is my understanding.
Yeah, it's another one that's constantly in. It's probably the biggest complaint people have about Tickle is that TK, out of the box, can still look
exactly, but yeah, people do. It has a reputation for looking a little classic. So it is nice to see it get some updating.
And that's been constantly going on since for the past dozen years or so, anyhow.
Cool. And of course, we spoke about Tickle OO a little bit, and as I said, having played with it a bit, it just feels like a modern object system, because it is a modern object system.
Yeah.
Not, I have to admit, necessarily what I expected to find in Tickle, but it's great. It's impressive. It's easy to use. It works the way you expect. It's easy to reason about. Those are all very good things. So I would expect anybody with any kind of a background would be able to just start using it um, having learned the 13 rules, and be able to produce very functional code that'll run on their phone.
Yep.
You do have some. Sorry, go ahead.
Yeah. And when you start playing harder with Tickle OO, you find out that it has the kinds of introspection features that you'd expect from a dynamic language.
Right.
So
very nice to have when you need it. Yeah.
Yeah, you can make a generic serialization routine because it can go in and introspect the class and say, here's how I serialize this class, instead of writing a separate serialization for every object.
Right. I spent quite a bit of time in the early 2000s building and maintaining code generators that did nothing but generate serialization code for C++ objects. And so not having to do that, that's a very good feature.
Yeah.
Cool. We are going to talk a little bit about, we have some data from a survey we did of our customers, so we'll talk about it in a bit, that gives us some insight into the industries where Tickle is being used, but suffice to say it is being used in a lot of places, well outside of pure software. And as I said, my experience with Tickle was primarily with the visualization toolkit, where all the testing was driven by Tickle. And that's the test automation is very much alive and well.
That was what actually got me into Tickle initially, was automating testing for a company I was working for.
Okay. Hardware or software testing? Because I know that Tickle is being used in both.
I started with the software and then ended up running the hardware test facility, the hot-cold boxes, power cycling. We got a factor of 10 out throughput improvement with the automation stuff.
Okay. Good. Environmental compilation is something I'm a little less familiar with in the Tickle world. Is that a core component of the Tickle distro these days?
Not yet. Got a paper on it last year's Tickle Conference and another one this year. We're seeing on some applications about a factor of 25 speed improvement. This is new stuff.
In certain respects, that factor of 25 is actually speaks to how efficient the Tickle interpreter is. Because without naming names, I know some other interpreted languages that have had similar work done on them, where it is more like a factor of 300 speed up, because their interpreters aren't as efficient as the Tickle interpreter is. But still, 25 is nothing to sneeze at.
No, it was that, and Richard Hipp of SQLite fame did a talk last year on micro-optimization techniques. It's where he's gotten a factor of 4 improvement on SQLite.
Cool.
And, we broke after his talk for a codathon and pulled another 1.5% out of Tickle right that afternoon.
Excellent. Every little bit helps, especially on small footprint systems. And I do think, if we get time, we should talk a little bit about, there have been some Tickle ports to very small systems, almost sort of Arduino scale, which I do think, well, here we have a mention of IoT apps, but I think there may be some interesting applications for Tickle in the small embedded world, because the interpreter is so clean and efficient.
Yeah.
So these are. Go ahead.
Several years ago, Karl Lumbauer did a talk on getting Tickle into 64K.
Cool. That would be tight.
Yeah.
Yeah. I might have to go down to 12 rules for that.
He did. He had to go back to Tickle 6.
Okay. Okay. And that is the balance in the language. Obviously, we want to see these powerful features added, but on the other hand, there is definite value in being very lightweight, very clean, very simple. And we do. So rapid prototyping, I totally get with Tickle. I'm mostly a Python guy when it comes to dynamic languages, and I've used a bunch of different GUI toolkits. And recently, last fall, did some work with tkinter, which is the Python TK system. And I was amazed by how clean, how fast, and how simple it was. compared to some of the much more heavyweight toolkits. So I'm kind of a born-again believer in TK as a tool for rapid prototyping. It really did what I wanted because it worked.
Yeah, yeah, I go through that a lot with my customers when I'm doing. Very often, people come to me with an idea on the back of a napkin,
Right.
and I can give them a GUI pretty quickly, and we can go through those iterations, and then I just start putting the code in underneath, and we get to a product fairly quickly.
Yeah, yeah, and it's great to be able to show customers right away. This is what it's going to look like, and this is how it's going to behave, because you can add behavior pretty simply.
Yeah.
And then, as we said, there's Android and potentially IoT apps. IoT is, of course, one of the big hot topics in the world right now. I've seen predictions that in 2018 there'll be more IoT connected devices than there are cell phones.
Okay.
So things with, either, low power wireless connections to some larger network, basically, or it's equivalent to that. Things with Bluetooth or something equivalent that are still networked, but are just a little bit of silicon with a few sensors to do whatever it is they do, and then you gather that data up and process it, feed it back to the user. And I can certainly see Tickle having a place in that universe.
Yeah, I've done a little bit of playing like that on the Raspberry Pi. It's
Right.
a prototyping with it, platform for that kind of thing.
Yeah, and Raspberry Pi it really is, with Pi Zero especially, you have a system which is selling, the whole system is selling for the price of a high-end programmable interrupt controller. So you can buy a PIC that's $5 to $7. And the Raspberry Pi Zero is in the same price range and does 10 times as much more. So I think there's something really exciting going on there in pushing the capability of low-end hardware. And if you put a clean, simple, lightweight language like Tickle on it, you're getting the maximum out of the hardware while still having something that's really friendly to program. Having worked in robotics and embedded in C and various, there are C subsets, or like Robot C, that's an even simpler C. Having a language like Tickle to work in that environment is a really nice thing.
Yeah, one of the things that I did as a demo for a talk I did on the Pi Wish was a robot arm and a sensor and a piece of paper with a black dot on it. And it would center the black dot. It's like, yeah, we did that in the 1980s, but it was $1 million worth of hardware and 6 months worth of coding. I did this with $100 in an afternoon.
Yeah, things we thought were complicated back then.
Yeah.
And we're just learning what we can do with this technology now. When we think about, you think about languages that are this powerful, hardware that is this cheap, in the hands of people everywhere, in China, in India, in Africa, in Europe, in North America, and South America. It's completely accessible, and I'm sure that people in a whole range of places are going to find amazing things that they can do with it. And Tickle is a great entry level, well, not just entry level, but a great language for approaching those sorts of problems, because it lets non-programmers express what they need to the machine in a very natural way.
Yeah.
We also hear a lot about, in our business, we hear a lot about DevOps, internal systems management, and I can certainly see Tickle having a role in that. That's not where it's been traditionally. From our point of view, we see more people using Perl in that space, but we do also see people using Tickle.
Yeah, I think you see, in my experience, the people with a CS background tend to like Python. People with a sysop background tend to like Perl because they've already learned Shell and awk.
Yeah.
And scientists, engineers, guys who took one programming course when they were in college tend to like Tickle.
Yeah. Yeah, I can certainly see that. Yeah. And then we also see it throughout the EDA FPGA space as a scripting language in design tools.
Yes.
And that to my mind is sort of the perfect Tickle use case. It's almost what it was made for.
Yeah, it is what it was made for.
Yeah, it really is. Yeah, I guess I shouldn't say almost. It actually is what it's made for, and it's still being used in that space very, very heavily. Almost 30 years later, 20 plus years later, which speaks to its power. Nothing has displaced it. There hasn't been a better Tickle coming along to do that job.
Yeah, I've seen a little bit. There was a talk several years ago on somebody putting the Tickle interpreter onto an FPGA.
Oh,
I haven't
cool.
seen anything since then. I don't know if it ever actually happened, but it was
Yeah.
going to be a single chip computer, the operating system, or the user interface.
Right. That would be very interesting. Yeah. The other area that's very hot right now are GPUs, and I've not seen anything about sort of Tickle for GPUs, but it might be there might be something interesting there. So we see a lot of people using OpenCL or libraries like that to push computations onto their GPU.
I would expect that where Tickle would come in there would be as an extension.
Right.
One of the libraries that pushes things onto the GPU, because there are extensions for Tickle for using R and Tickle. I'm trying to remember what it is. Some of the massively parallel stuff.
Right. Okay. Cool. And of course, we do also see we have customers who are certainly using Tickle in absolute mission critical areas where they like the language's simplicity and reliability more than anything else.
Yeah, the hardware test facility that I mentioned ran 724 for years until they decommissioned the factory.
Right. Yeah. And you don't need anything experimental when you're doing that. You want something which is really solid and tried and true. And it's interesting that Tickle does keep on adding features, but what gets delivered is a very solid language. Ultimately, it's not like they're pushing experimental stuff into the core.
No, we tried very hard to not let anything out the door until it's solid.
Yeah.
Once in a while, bugs do get out, but they're usually edge cases.
Yeah, but it is for its power, and of course the quick learning curve, especially for non-developers, is a big deal. That some of us are in love with languages, and some of us just want to get the job done. Tickle is, I think, always going to be a good tool for people who just want to get the job done. It's what it's designed for. So we asked. Pardon me?
Yeah, one of the things I noticed recently with Tickle is a lot of the people who use it never learned it. They just sat down and looked at it.
To be honest, I'm in that category. I needed to do stuff with it, and I had examples of it, so I learned enough to get along. But it wasn't. I don't think I ever read even a tutorial on it, or hardly a tutorial. But you can do that with Tickle. Yeah.
You don't do that with C++ or even C.
No, not at all. So we asked a bunch of our customers, or at least a bunch of people who downloaded ActiveTickle, who they were, what they were using it for, where they were, and we got a few hundred responses, which, in fact, this is one of the questions we asked them, which is, how long have you been using Tickle? And with a lot of our languages, we've kind of expected, because the languages have been around for a long time, they aren't the shiny new thing. We've kind of expected that people would tend toward the older end of the spectrum, having used the language for a longer period of time, that they learned it in the 90s and decided that this is a language they like, and they're not going to change. Whereas what we found is, as you can see here, a third of people have been using Tickle for a relatively short length of time. Well, actually almost half, more than half, I guess, have been using the language for less than 3 years. And admittedly, some of that may reflect our, the population that we're polling, because there are people who have downloaded ActiveTickle in the last year or two. But it still, I think, speaks to the fact that the language has a vibrant and relatively young user community around it. The people are coming to Tickle because it solves the problems that they have, not because they've always used it. It's attracting new users, as well as, and then you can see it also has a loyal following. The 40% who've been using it for 10 years or more are the people who have picked it up in the 90s and never let go of it because it continues to solve their problems. So I think it's an interesting mix, or an interesting story that this picture tells, that we have both loyal long-term users and new, fresh ones.
In my training sessions, I see, of course, people who are new to the language, but I see about the same age distribution of kids who are fresh out of school and guys who have been on the job for 10 or 20 years.
Right, right. Well, it's good to see. It is. And you're training mostly in corporate contexts where companies are adopting the language, or?
Yes. Yeah, either adopting it fresh or expanding their use.
Right, right. And how does that break down? Do you have any sense of what fraction is which?
Most of the ones who've been calling me the past couple of years have been doing testing applications. So they're building a big test system for hardware.
Okay. Cool.
I get called occasionally from people doing health stuff, because Cloverleaf uses Tickle for one of its configuration tools.
Okay. But so basically there's a significant fraction of new use in there where people are building a new test system and they decide Tickle is the way to go. Yeah. It's a very compelling, from a purely engineering point of view, I think it's a very compelling choice. When you're facing that problem, it's hard to think of a viable alternative to Tickle, or a better alternative to Tickle. This is the other thing that I think is really interesting. As I said, we get a huge diversity of people in the Tickle community. That a lot of users, admittedly, are in software. We get a fair number in QA, and these are job titles. But we also get an extraordinarily large fraction of others that include professors, technologists, design engineers of all kinds, who are, to my mind, the core audience for Tickle as a language.
Agreed.
And they're
agreed, because sorry.
Go ahead.
Yeah, that's what I see most often, is that the people who come to the Tickle Conference are most often not computer programmers. They do a lot of development, but they are primarily a scientist or an engineer doing something else. GE researchers. Yeah,
and I like the range that we got here. That it really covers all different areas of technology, and both in academia and industry, and it really reflects on the utility of the language for these people. And I presume your training work is similar, where you're primarily you're talking to a lot of engineers, people like this.
Yeah, most often people that are not skilled programmers, because a skilled programmer can pick up Tickle in an afternoon.
Right.
I've given the Tickle Tutor tutorial to kids fresh out of college, and they were writing production code the next day.
Cool. Yeah, you can't do that in C++. So this is another question for our audience, which is what industry are they in? Because this is another one where we were curious not just who was using it, but where they were using it. We knew that there would be a lot of electronic design type work. We knew that there'd probably be testing of one kind or another, but we also knew that there would be this huge diversity of other stuff that we didn't, we weren't necessarily aware of. And indeed, we got a huge diversity of other stuff that a lot of software, obviously, unsurprisingly, but also healthcare and finance, which I didn't really expect, aerospace and defense as well. That we knew it was being used in some aerospace, but it was a bigger fraction than I expected. And then this very large, 1/3 everything else from education, telecoms, mining, biotechnology, chemistry, just a huge diversity of industry areas.
Yeah. One of the places where Tickle really excels is as a glue language, and that may be where some of the aerospace defense stuff comes from.
As a glue language.
Yeah. Project I did for the Navy a few years ago. They have very good high-power simulations for how a ship behaves when something bad happens, but they didn't have anything that would tie them all together and say the flooding in the electrical room just lost you power, and that's why you don't have any fire suppression anymore. And now somebody's fixed it, and you do have fire suppression. And Tickle was just perfect for that, because we could tie everything together, we could talk to all the other pieces.
Cool.
And
yeah, and I can see that, and it's and I can imagine that in a laboratory environment, for example, you always have different instruments producing different data formats on different time schedules, what have you. So having some Tickle to hold it all together, and putting it all in an SQLite database, which is actually one of my favorite things about Tickle. I mean, I know SQLite SQLite gets described as a Tickle extension that got into the wild, but even without all the other good Tickle has done in the world, SQLite is just one of the great shining lights in my life. Whenever I need a little database that I know is going to be powerful, reasonably scalable, lightweight, and easy to use in an application, I've got SQLite.
Yeah.
That's just a real. I don't know how much that plays into Tickle adoption, but it should be. it should be important.
Yeah.
Although I've used it in non-Tickle contexts a lot.
Yeah, it gets used almost every place nowadays.
Yeah. It's a lovely piece of technology. So as we see, there's a lot of non-developers working outside of the software industry in Tickle. This is another interesting question because we wanted to know what version of Tickle people were using. Different industries, different organizations, different individuals upgrade on different schedules. I personally am a bit of a late adopter when it comes to new technology. I like other people to find the bugs first. And we see this in all the languages at ActiveState. Cells, depending on the use case, depending on the enterprise, the size of the enterprise, there could be quite a bit of variability in how rapidly people move up to the next version of the language. And it also speaks to how rapidly the language is moving. Are people adopting the latest version because it has stuff that they really need, or are they relatively happy with a few versions back because it does pretty much everything they want? And what we found is that we actually, in the Tickle world, everybody is running pretty modern versions overall. We don't see, the other is mostly Tickle 8.4 versions. I don't think we had anybody who was certainly before Tickle 8.3. And we see a lot of people who are on something which is really quite recent, which I think speaks to the power that is being added to the language. And as you said, the major versions are the time to break things, but the backward compatibility of the most recent 8.5 and 8.6 versions is very good. So people are comfortable upgrading.
Yeah. Yeah, we do put a lot of effort into making sure that all of the old code still runs so we don't break things.
Yes. Which is really what you want as a language user. I want to be able to get all the new shiny stuff. I want to be able to get Tickle OO built into the language, for example. I want to get coroutines. But I want my Tickle 8.5 code to keep just working.
Yeah.
It is, I think it speaks very well for the backward compatibility of the language that this is the case.
Yeah, the ones that I see that are slower to adopt are commercial clients that have modified the core, that have their own tweaks in the core rather than doing a proper design with extensions.
Yeah, and that is, I'll plug ActiveTickle for a moment because those are things that we do for enterprise clients where if people need tweaked versions, we can produce them and then port those tweaks to later versions of the language as they come along, which allows them to upgrade, keep on the upgrade cycle more easily.
And that's a good feature because that can be very painful. I've seen companies take months to do that upgrade.
Absolutely, yeah, because you really need, with a custom version of the core, you really need to make sure that it's thoroughly QA'd before you let it out in the wild. Yeah. Frightening experience. I would not want to be an IT manager in that environment. So there is a Tickle Conference coming up in November. ActiveState is submitting a paper for it, and as we were speaking earlier, you said you will be there. Are you talking?
Yes, I'll be doing a talk on taking a prototype and turning it into a real product, taking it into a commercial, sitting out there on the web. You can download it and run it on your computer.
Excellent. And you have, in fact, because you've been through this process with a product quite recently, whose name escapes me, although I did download it and play.
Okay, yeah, it's called AndroWish, and it is a tool for helping writers improve their writing.
Right, yes. Yeah, which I'm very excited about. Yeah, I haven't run it on any of my own work yet, but I have played around with similar tools, and I think that there's great promise in that area, but the tools I've worked with so far have not lived up to that promise. So I think it's definitely an interesting area that needs more work done on it.
Yeah, there's a bunch of stuff that I still got planned for AndroWish, but I've been using it on my writing, and I'm doing a new book right now that I'm using it to edit and correct.
Cool, good. Well, it's still on my list of things to experiment with. And this is where you can be found.
Yep.
And this is where ActiveState can be found up in sunny Vancouver. And it's not really sunny. Not today. We've had some sun over the summer. And we do have the opportunity to take some questions from the audience as we have left. So here we go. We have BLT RBC's vector and graph widgets are a must-have in my current test automation in-house tools. Is there any more work expected to get a closer incorporation into Tickle PK?
Various pieces of BLT have been incorporated into Tickle recently. The busy widget got pulled in. I used to use BLT's graph widget, and then I discovered that once we moved into the Tickle object, graphs ran fast enough for me just writing them in pure Tickle. I've been using a tool that I wrote in just pure Tickle. There's one in the TK library.
You've been writing your own graphs?
Yeah, because there wasn't another one out there at the time.
Okay. Maybe you should release that. It's often a lot of work, let's say.
Yeah, there is one in the Tickle and TK library. Arjen Marcus of Delft Hydraulics wrote it.
Okay. So there are some alternatives out there as well as some pieces of BLT.
Yeah, the BLT graph uses a vector widget that got written because back then Tickle was slow. This is back in the Tickle 7 era.
Right.
And he needed that vector widget in order to do graphs quickly.
Right.
And that's just not necessary anymore.
Okay. That's interesting. Good. How can I start to read the Tickle code? That, assuming that means the code for the interpreter, download it, unzip it, and open it up. I don't know, is there any good guide in terms of documentation for the Tickle core?
I would look at Osterhout's book and Brent Welch's book, because they both talk about the internals a fair amount. I'll put in a plug here. I think the Brent's book is the best reference book. I think my book is the best tutorial book.
Cool. Okay.
So,
but your book is more focused on Tickle from a user's perspective.
yeah, and solving problems and
Yeah.
enough about the internals to write an extension if you need to. But
Okay, well that's fair enough. Yeah, and that's actually a good point. Is looking at guides to writing extensions may be a good place to start to understanding the Tickle core, because
yeah.
it's just great, you have a clean interface and you can work inward from there, essentially. Good. Windows printing has been a big challenge for Tickle TK in the past. Has any recent work been done to improve that?
I just dropped his name, but the package is CAWT. It's built on top of Twappy, and one of the reasons that drove this was the need to print on Windows. And what it'll do is it lets you open up a Word application and print things into Word and get out from there.
Okay. Yeah.
There was also a Tickle printing project that we did as part of Google Summer of Code that generates PDFs.
Right. Well, that's very nice. That's good. I find that funny because I've been a Linux user since 1993, and I still find printing on Linux a pain, whereas printing on Windows almost always just works. So I'm sure there's got to be ways to make that easy. And actually, the idea of putting it into a Word doc or a PDF is not a bad one at all, because you're in control of the format and you know that it will print.
Yeah.
I had problems with rewrap and star kits where they had hard paths to directories. I'm wondering if TickleKit makes that automatic or if these other tools have easy ways to do it. These are the sorts of questions where I should have my Tickle lead on the call.
There should not be hard paths built into a star kit or a free wrap. But sometimes it's easy enough to let them sneak in. When I'm working with Tickle kits or star kits, I always have a precursor in my code that says, if in StarQuit, set my source dir here. Otherwise, set my source dir there. And then everything is sourced and accessed via those.
Yeah, we have certainly seen there are places where you can get hard-coded paths in the compiled code that, as part of our process, we make sure go away. So it can take a little bit of extra work to do that.
Yeah.
That's the only thing I can say to that. And you can always go in and edit the binary. That might not be the most helpful advice. A statement rather than a question. I find Tickle is great for exploratory coding on problems that aren't well defined, or many types of equipment need pulling together. Yeah.
Yep.
That's it. One of the comments, ActiveState produces Komodo IDE, which is a integrated development environment optimized for dynamic languages. And my dev lead on that sometimes describes it as a tool that gets out of your way. And I kind of feel the same with Tickle, that it is a tool that gets out of my way. It does what I want it to do, whereas C++, for example, is a tool that gets in my way. Right? When I have a problem that needs C++, I spend a good half my time thinking about C++, not the problem. Whereas with Tickle, I spend 90% of my time thinking about the problem and 10% thinking about Tickle.
Yeah, one of my clients several years ago was a large corporation that used Tickle for their assembly line because when they got a new device, they could call me up in about 3 days. I could take the library, figure out how it worked, and now they have a color sorter on their line that looks at things.
Right. Yeah. Yeah, that's good. Tom, I recently saw your Tickle in Space article and found it really interesting. Can speak more about Tickle's use for space technologies. It's everywhere. We have, I can't name customers, and I don't know, do you have any clients, Clif, who are working in aerospace or working in space?
I have done training for groups that are, yes,
Yeah.
and satellites.
Okay, yeah.
Mostly in testing data on the satellite stuff.
Okay. We have a number, or at least there are a number of groups who have Tickle as part of everything from spacecraft guidance and simulation, for example, data processing on the back end. So you get, terabytes of data from your satellite system, from your planetary exploration spacecraft, what have you. And there's a lot of Tickle used in the processing. And there are at least a couple of cases where there is actually Tickle on the spacecraft running particular devices. Basically, it comes as part of a particular spectroscope or something like that, where there's some instrument on the spacecraft that is running Tickle, is my understanding. So it is a technology, because it's used in so many devices, it is a technology that just pops up everywhere without people realizing that it's there. You don't think of it.
Yeah, it's another one of those points where the people who use it are scientists. They're not trained programmers. They're trained scientists.
Yeah, absolutely. Or engineers, And if you're building a complex instrument that needs an internal control system, embedding Tickle into it is a very logical and natural way to do that.
Yeah.
And we have one more question here. Will we ever get a 64-bit or a Tickle library?
I don't know. I'll admit I haven't been using Oracle that much lately, so I haven't paid attention to that part of the world.
Yeah, nor have I. So that it's always a possibility, but I guess it's a matter of finding people in the community who are sufficiently enthused and interested to push it in that direction. Yeah. And that's part of the Tickle balance is, as a small language, as a lightweight language, it's awfully good on 32-bit systems. Particularly like the smaller footprint ARM type systems. So while it does full 64-bit thing, it also gets a lot of love in the smaller areas.
Yeah, and it's very much a pragmatic language. If somebody needs that, somebody's going to write it. That's the reason that Oracle existed in the first place.
Yep. Yeah. So that is undoubtedly true. So we have no more questions, but I am reminded to remind everyone that we will post the recording and the slides, so that if you missed it, can come back, or if people want to show it to other people, can download it and show it to others. So thank you very much for joining us, Clif. This has been enlightening and interesting.
Okay, thank you for inviting me. It was a lot of fun.
Great. Okay.